dear little champions, welcome to day 18 of 99% in 99 days. So today we are going to cover the second part of the chapter acids, bases and salts. We'll be talking about salt, its types and all the different compounds that is there. Okay, so please watch this complete video, and at the end of the concept we'll be practicing some important questions as well. Okay, so yes, now coming with this, so we have already done. So in salts today we are going to discuss salts, the type of salts and the important compounds. Okay, so now when you talk about type of salts, so basically we know that what is a salt. So what is a salt? A salt is produced due to the reactions of acids and bases. Okay, and this type of reactions are called as neutralization reactions, right? Clear? Now the salts can be of three types. Okay, acidic salt, basic salt and neutral salt. Now see, acidic salts are those salts where we have strong acid and weak base. Okay, strong acid and weak base, and because it is a strong acid, it will be acidic salt and the pH will be less than 7. And you remember the pH range for acidic is from 0 to 7. Okay, and for base it is 7.1 to 14. Next example you can see here, NH4Cl. So if you see the base and the salt here, it is NH4OH, okay, plus HCl, right? Now this is a weak base, okay, and this is a strong acid. Now when these two will react, what we will get? Salt plus water. Clear? Next, coming to basic salts. So basic salts are those where we have a strong base and a weak acid. Okay. Now strong base can be like, for example, CH3COONA. So you can see here the acid is CH3COOH and the base is NaOH, right? So this is a strong base and this is a weak acid. Okay. Now the pH of these type of salts will be more than 7 because it is a basic salt. Okay. Next, coming to neutral salts. So neutral salts are those salts where you have a strong acid and a strong base. Okay. So it is made up of NaOH plus HCl, suppose. So NaOH is a strong base and HCl is a strong acid, right? Now when these two are reacting, a strong base and a strong acid, we get neutral salt and the pH is less than, pH is equal to 7. Okay, so three types of salt: acidic, basic and neutral. In acidic salt you need to take strong acid, the pH will be less than 7. In basic salt you need to take a strong base, pH will be more than 7, and in neutral salt the pH will be equal to 7, and you need to take a strong acid and a strong base. Okay, fine. Now we'll go to some important compounds. Okay, so we all know what is the formula of common salt, that is NaCl. Okay, but this common salt, okay, can be used, not it itself has a lot of uses. It is one of the most important ingredient that we use in our food items and all, right? But NaCl or sodium chloride can also be used to prepare different types of other important compounds. Okay, it can be used to prepare bleaching powder, baking soda, washing soda and plaster of Paris. So we'll be seeing how can we use these all things to prepare these different compounds, and we'll see their uses and all. Okay, so this is completely something that you need to remember. Okay, so first coming to the first thing, that is sodium hydroxide. The first one, that is sodium hydroxide. How can we prepare that using sodium chloride? Now see, when electricity is passed through an aqueous solution of sodium chloride called brine. So this is also a very important question. What is brine? Brine is nothing but aqueous solution of sodium chloride. Okay, it decomposes to form sodium hydroxide. The process is called as chlor-alkali process. Okay. Now you can see here, if you have taken aqueous NaCl, so you have Na plus, you have Cl minus, you have H plus and you have OH minus. Okay, so now what will happen when you are doing electrolysis? You have one electrode and one anode, right? So there is a cathode and there is a anode. So towards the anode what will happen? The positive ions will move, so Na plus will move and H plus will move, and towards the cathode, sorry, one small mistake here, symbol, one second. Yeah, so now what happens here is you have a positive electrode and a negative electrode. The positive electrode is called as anode, okay, and the negative electrode is called as cathode. Now what happens? These positive, okay, now what happens? these positive ions, okay, will get attracted towards the cathode, okay, so Na plus and H plus, and these negative ions will get attracted towards the positive electrode. So now what happens, we have H plus here and Na plus. So out of these two, H plus will undergo reaction here and chlorine will undergo reaction here. So during this process, NaOH is remaining in the solution, H plus will get convert to H2 and Cl2 will be formed at anode. Okay, so that you can see here, you have here Na plus ions and OH minus. So OH minus and Cl minus is moving towards the anode and Na plus and H plus will move towards the cathode. But again, if you compare these two, H plus will move, and if you compare these two, Cl minus will move. And in the solution, what is left? Na plus and OH minus. So NaOH remains in the solution, chlorine is produced at anode, H2 is produced at cathode. Okay, so that is why this is called as a chlor-alkali process, because in this process we get chlorine, one alkali and hydrogen. Okay, now what happens when this is the reaction that takes place in case of this one. Okay, now if you see what are the uses, so what is the use of sodium hydroxide? It is used in soaps and detergents, in paper making and in artificial fibers. Okay, the H2 gas that is produced can be used as a fuel, used in margarine and used in ammonia for fertilizers. Okay. Next, chlorine, it is used in water treatment, swimming pools and in disinfectants and pesticides. These are different uses. You should remember the use of NaOH. Okay. Now coming to the second compound, that is bleaching powder. Okay, how is bleaching powder prepared? So now you see the chemical nature of bleaching powder is calcium oxychloride, CaOCl2. Okay. Now you see the using NaCl, when we do electrolysis of NaCl, we got chlorine, right? This chlorine reacts with calcium hydroxide to give you CaOCl2, which is nothing but your bleaching powder. Okay, so NaCl is not directly involved here in the preparation of bleaching powder, but when you do electrolysis of NaCl, we get chlorine molecule or Cl2 gas, which reacts with calcium hydroxide to give you calcium oxychloride, or we call it that as bleaching powder. Okay, so it has many uses. It is used in bleaching of cotton, it is used as an oxidizing agent in chemical industries, and it is used for disinfection of water. Okay, now coming to the next one, that is your baking soda. Okay, this is also very important. Baking soda formula is sodium bicarbonate, that is NaHCO3. Okay, now produced by treating cold and concentrated solution of sodium chloride with ammonia and carbon dioxide. So you can see here again sodium chloride is used, or how can sodium chloride be used to prepare this particular compound, that is baking soda. So NaCl, if you treat it water and with CO2 and NH3, okay, water, CO2 and NH3, we get NH4Cl and NaHCO3, which is nothing but your baking soda. Okay, now if you heat this baking soda, okay, it breaks down to give you Na2CO3, H2O and CO2. Okay, now this carbon dioxide which is produced here, okay, is responsible for making your cakes and all fluffy and spongy. Okay, so it is used as an antacid to treat acidity in the stomach. Okay, this we have already seen in the previous class. It is used to make baking powder, which is used in the preparation of cakes and bread, etc. Okay, so baking powder, okay, if you see baking powder is made up of two things. One is your baking soda, okay, baking soda and tartaric acid. Okay, so now if you remember the reactions of acid and bicarbonates, it gives you carbon dioxide, right? So that is why when you use baking powder, the cake becomes more spongy and fluffy. Now coming to the fourth compound, that is washing soda. So washing soda is Na2CO3. The chemical nature of bleaching, okay, sorry, this one is washing soda. Okay, the chemical nature of washing soda is sodium carbonate, Na2CO3 dot 10H2O. Okay, Na2CO3 dot 10H2O. What are its uses? Used in glass, soap and paper industries. Employed in the manufacture of sodium compounds such as borax. Okay, washing soda is used for borax. Next you have remove permanent hardness from water. Okay, so till now what all uses, what all compounds we have seen? First one is sodium hydroxide. Okay, then one is bleaching powder. Next you have baking soda, and then you have washing soda. Okay, these are the 4 compounds which can be prepared from what? From NaCl. Okay, if you do electrolysis of NaCl, we'll get NaOH. In that process, chlorine is produced which reacts with calcium hydroxide to give you bleaching powder. Now, if you take NaCl and then treat it with water and ammonia, right? Water, ammonia and carbon dioxide, then we will get this one, NaHCO3, right? That is your baking soda. And if you heat NaHCO3, you can see here, you will get washing soda. Okay, fine. So now we'll go to the next compound. So this is not a compound that is prepared from NaCl, but yes, it is another important compound, that is plaster of Paris. The chemical nature of plaster of Paris is calcium sulfate hemihydrate, means CaSO4 dot half H2O. Okay, now plaster of Paris is prepared by heating gypsum at 373 Kelvin. This is very important point. If you heat other than this temperature, of if you heat at a higher temperature, then you will not be getting this one, you will not be getting plaster of Paris. Okay, so you need to heat exactly at 373 Kelvin, not higher than that. Next, on heating it loses water molecules and becomes calcium sulfate hemihydrate. Okay, so this is CaSO4.2H2O, that is your gypsum. Okay, and when you heat gypsum, you get calcium sulfate dot half H2O plus 1.5 water molecule. Okay, now what are the uses of this one? It is used in many purposes. It is used to fix gaps in wall, roof, buildings and houses. It is used in making casting for several ornaments. It is used for designing products for the protection system. Okay, so now we can do something about water of crystallization. What is water of crystallization? Now see, water of crystallization is the fixed number of water molecules present in one formula unit of a salt. Next thing, it is a dry salt. If you have water of crystallization, till the salt will be dry, you won't feel the water molecules. Okay, it is present inside somewhere. You cannot feel and tell that it is a wet salt. It is not wet, it is a dry salt. Example here are copper sulfate dot 5H2O. Okay, next we just saw now washing soda, that is Na2CO3 dot 10H2O. Then we have next one is just now one more, gypsum, calcium sulfate dot half H2O. Okay, so these are the examples of water of crystallization where these salts are present with water. When you heat it, these water molecules will evaporate, but they are not wet salts. Okay, fine. Now here's something very important announcement, students. So as I always tell you, 10th is a very important turning point in your career. After this, which stream you are choosing, that is very important, and you must take this decision with expert advice, right? So to help you with this, we have DSAT, that is Diksha Scholastic Aptitude Test. So here what is happening is you will be getting a 60-minute lecture, concept based lecture. You will have a test on this, and then your paper will be evaluated with then you will have a one-on-one mentorship with a mentor who will be evaluating your weakness, strength, and make you understand the best career for you. Okay, so please do not miss this opportunity. So if you want to register for DSAT, then please go to the description section, the link is there, you can register there and join this program. Okay, fine. Next we can go. So now we will practice few questions from the concepts that we studied now. Okay, identify the basic salt from the following salts. Okay, basic salt, if you remember, you should have a strong base and a weak acid. Okay, so now what I'll do is for each of these options I'll write the basic salt, acid plus base. Na2CO3, it is made up of NaOH plus carbonic acid, that is H2CO3. Yeah, this is a strong base and this is a weak acid, so definitely the answer here is option number A. Okay, next, but if you see NH4Cl, it is made up of NH4OH plus HCl. So this is your weak base and strong acid. Okay. Next we have NaNO3, NaOH plus HNO3. Okay. So this is again strong base and strong acid. Next D1 is KCl, so that is KOH plus HCl. Okay. So this is again strong base and strong acid. So you can see option number A is your correct answer and it is a basic salt. Okay, next question number 2 is washing soda is hydrated. So washing soda is hydrated sodium carbonate Na2CO3 dot 10H2O. So that is sodium carbonate, option number D here. Okay. Now let us do some assertion reason questions. Fresh milk in which baking soda is added takes longer time to set as a curd. Yes, that is correct, because when you leave milk for a long period of time, bacteria act on it and produce lactic acid, which makes the milk sour, right? But if you add some baking soda, then it neutralizes the lactic acid and it doesn't allow the bacteria to grow and produce lactic acid, right? So baking soda decreases the pH value of the fresh milk to below 6. No, now you see, baking soda is a base. Okay, now if it is added, the pH will be greater than 7. Okay, so that is why assertion is correct but reason is false. So that is your option number C here. Okay. Next question number 2. After whitewashing the walls, a shiny white finish on walls is obtained after 2 or 3 days. Okay. Now calcium oxide reacts with carbon dioxide to form calcium hydrogen carbonate, which gives shiny white finish. Yes, this is correct. Now when you have calcium oxide, okay, and it reacts with calcium carbonate, carbon dioxide, you get calcium carbonate. Okay, this is the reason why we get a white shiny appearance. Okay, so both assertion and reason is true and reason is the explanation. So correct answer is option number A here. Okay, next we'll do some 2-marker question here. Diana prepared a cake by 2 methods. What is method 1? She added baking soda. Okay, what is baking soda? Baking soda is NaHCO3. Okay, NaHCO3 to the cake mixture and let the mixture stand for 1 hour before placing it in the oven to bake. Method 2, she added baking powder. Okay, so baking powder is what? NaHCO3 plus tartaric acid. Okay, and let the mixture stand for 1 hour before placing it in the oven to bake. State the difference in the cake mixture that Diana is likely to have absorbed before baking. Explain why. So you will see that before baking, okay, the second one in which you have baking powder will be fluffy, will be spongy, will be swollen. Okay, now that is because of when NaHCO3 reacts with tartaric acid, what happens? Any bicarbonates reacting with acid will give you salt, carbon dioxide and water, right? So the carbon dioxide gas is formed, which will be formed in the form of bubbles, and it will form a floppy and spongy appearance. Okay, so you can see the answer here. Diana is likely to see that the cake 2 mixture has risen while cake 1 mixture has not. Okay, risen means it has become large in size. Okay, it has swollen. Now what is the reason? The sodium bicarbonate and the tartaric acid in baking powder react on mixing with one another, producing carbon dioxide that causes the cake mixture to rise. Okay, so gas bubbles are formed. The gas bubbles will evaporate or they will move up, and in that case this one forms a swollen. Baking soda does not contain tartaric acid and hence does not produce carbon dioxide before baking. Okay, but when you heat it, okay, when you start heating the baking baking soda, NaHCO3, when it gets heated, it breaks to Na2CO3, CO2 and water. So that is why there also, after the cake is formed, carbon dioxide will be there definitely and it will be swollen. Okay, but before baking you can't find swollen if you have just added baking soda. Clear? Next question is of 3-marker. So this is your brine method. Okay, identify the gases evolved at anode and at cathode in the experimental setup. Okay, so if you have seen in brine solution we have Na plus, Cl minus, H plus and OH minus. Okay. Now here what happens, out of Na plus and H plus, so this will move towards the negative electrode and this one will move towards the positive electrode, right? That is anode and cathode. So H plus will move towards cathode. So at cathode which gas is produced? H2. At anode which gas is produced? Cl2, right? So what I can say, so at anode I'll get Cl2 and at cathode I'll get H2. Done. Next, name the process that occurs. Why is it called so? So the name of the process is chloralkali process. And why is it called so? Because of the production of an alkali, a chlorine group and a hydrogen group, right? Next, you have illustrate the reaction with of the process with the help of a chemical equation. So you can see NaCl with water will give you NaOH plus Cl2 plus H2. The reaction is balanced. Clear? Okay. Now we will go towards the next question. Okay. 4 samples are there, A, B, C, D. Change the color of pH paper or solution to green, reddish, pink, blue and orange. Their pH was recorded 7 to 10.5, 6 respectively. Which of the samples has the highest amount of hydrogen ion concentration? Highest amount of hydrogen ion concentration. So if you see, okay, so I can say that A has a pH of 7, B has a pH of 2, C 10.5 and D is 6, right? So lower is the pH, more is the acidic character, more will be the concentration of H plus ions. So which is having highest here? So that is definitely the answer for A, first part is definitely option number or sample B. Okay. Arrange the 4 samples in the decreasing order of their pH. So you can see what pH is maximum for 10.5. Okay. 1 second. Color of A, B, C, D also we need to check. I think A is green, okay, B highly acidic, so it should be reddish, C 10.5 is blue, yeah, and 6 is orange, yeah, that is correct here. Okay. Okay, so we have to arrange them in the decreasing order of their pH. So the first one is your C, so I can write C, okay, then I have D, no, after that A, okay, and after that D, and after that B. Okay. Next, Rahul found that the plaster of Paris which is stored in a container has become very hard and lost its binding nature. What is the reason for this? Okay, so yeah, so what is the reason for this? So what happens when you have left the plaster of Paris, that is calcium sulfate dot half H2O, okay, it gains water, okay, half H, it gains water and becomes calcium sulfate dot 2H2O and it forms gypsum, right? And that is why this does not have any binding properties. Okay, you also write the chemical equation. So this is the chemical equation. Give any one use of plaster of Paris other than for plastering or for smoothing of walls. So it is used to make decorative items. Okay, clear? Okay. Now in this chapter there are some important topics that you must revise. Okay, the first and the very important topic is reactions of acids and bases. Here you should know with reactions with metals, reactions with oxides, right? Then you have reactions with carbonates. Okay, so these are the important things that you should revise. Next, you should revise salt and its types, which are the example of acidic salt, basic salt, neutral salt, that all you should know. Important compounds, all the formulas and uses, then pH in everyday life. This is also very important topic. Okay, so once again students, I want to remind you about DSAT. So if you want a proper guidance about your career, what option you should choose, which stream you should go, then definitely please register for DSAT. I have already explained you what is DSAT. So there will be a 60-minute lecture, then you will be attempting a test, it will be evaluated. Then there will be a one-on-one counseling where you will be knowing about your strength and weakness, and based on that you can choose your career. Okay, so this is going to be a very good opportunity to explore different to know your strength and weakness and to make the best career option choice. So please, if you want to appear in this DSAT, the registration link is there in the description section. Go there, register it, and then you can appear in this DSAT and can choose the best career for you. Okay. So yes students, that's what in this lecture. In tomorrow's class we are going to study about, we are going to practice questions from acids, bases and salts. So we are coming tomorrow with a lot of previous year questions, sample paper questions of CBSE. So please stay tuned and subscribe the channel for more such videos.